Well, hi, and welcome to my shop. Thanks a lot for joining me. Today I'm going to be spending probably most of my time studying this diagram and this diagram during this video. So if you're hoping to see a soldering iron flying around, I don't think it's going to happen. So the situation I'm in with this radio is it has been altered by the previous repair person, who seemed to be a fairly thoughtful person. He had very serious alterations. Some of it, the primary source of it, is the changing of the IF coil in here, which seems to have sparked a couple other changes. One is a number of components have been removed. They're just gone. They don't exist in the radio. And secondly, with those components missing, the way in which the magic eye has been connected is an alternative way, and I think an inappropriate way in my mind. So what I'm facing is the basic question of what am I going to do about this? The radio appears to work, magic eye appears to work. I don't think it's performing the way it should, but the radio is working. Also, I've seen enough of the last guy's work to know that this guy wasn't a fool, and the things he was doing were probably all extremely rational. So that means that the situation that's here now may be the best rational solution given the fact that this coil was changed. And I don't understand how that could be. Another possibility is the guy just decided all these extra parts that had already come out for some reason just didn't make that much difference. And so who needs them? And so out they go. The result of that could be things like variations in volume, variations in tonal quality, tonal response, distortion, stuff like that. Could be because of this change, but I don't know. The radio sounds pretty good. It's not fully tuned up. I've never tuned up the front end of this radio yet, so I really don't know what this would sound like if it were performing as best as it can in its current state. So now a little bit of extra pressure. The owner is very interested in having this radio restored back to its original circuit arrangement. So there's a little bit of pressure there to go ahead and reinstall all the parts that are missing somehow, somewhere in here. So that's kind of what I'm facing right now. What should I do next? I can go all the way from leave it all just as it is to attempt to restore it right back to the way it appears on the schematic down here. So let's start with this schematic here. Below it I have my own diagram, which would be a little easier to work with than this. So I apologize, I showed this schematic on my last video, and I showed the connection, the very important connection between the audio output of the detector and the rest of the radio. I showed the connection here. It's not here. It's actually made right up here, right up on this terminal, in fact. So this is not right. This is more appropriate, just in case you're able to see this stuff and you're thinking hard about it. So I apologize if that's been a little misleading. So this is the same as this. This is not how the radio is. This is how the schematic is. So I'm going to spend a little bit of time studying this and thinking about it. There's a reason why the designers put all these parts in the radio, and I don't know what the reason is. Now there's some standard stuff we can probably sort out pretty quick on our own, but there may be some little things going on in here that, for the life of us, unless the design engineer showed up and explained why they did that, we probably will never figure it out. So now this is a very complicated looking thing, but we can simplify it an awful lot. If I just grab my very powerful visual blockers. Let's put one blocker here, one blocker here. Okay, so looking at this chain coming from the top of the tube, let's call this the output of the tube, we can call it that, comes down through this resistor to the chassis. Let's just think about that. It comes from here, through this coil, and two resistors to the chassis. Okay, thought there might be something funny there. Nothing funny on those sticks. So through the coil, through the resistor, through the resistor. Now let's look at the size of these resistors. So I've written them all out in longhand. I haven't used a K or an M, you know, for 1,000 or a million, so that they'd be a little bit graphical. So the smaller resistor is going to have a shorter number, like that, 27. And the bigger resistors are going to have a longer number, like that. So kind of at a glance, you can kind of see pretty quickly that this and this are actually fairly low resistances compared to this guy over here and compared to this guy. So from the point of view of the tube, you know, and bear in mind, I'm thinking this through as I talk, so I'm going to wander off and make mistakes here and have to circle back on the wagons and all that kind of stuff. So hopefully you've strapped on your seatbelt for this. So we're coming down through here. There is some resistance here. What kind of resistance would be in here? I don't really know offhand. Maybe 1,000 ohms. I don't really know. I don't think it compares to this. It certainly doesn't compare to that. Pretend this doesn't exist DC wise. Just thinking about the DC part of this circuit right now. So basically this is a voltage divider. 60 here and 10 there. So most of it here, little of it there. Most of it falling here, all of it falling across here. We could put it that way. So what's falling? The DC result from the diodes up here and the current flow from it coming down here. And what's that going to look like? I should draw this out again. This is what I believe it to be. So if we can actually do this, you know what? We're going to do this. Hey, we're going to have some fun. We'll hook up the scope and see how many of these things are correct. What you would see here, if you had a nice, like maybe a 1,000 hertz tone being received by the radio, I think you would see something like this. Pardon me for my poor drawing here. You would see something like this, only this would be filled in. This is the high frequency. This is the 455 here. These are the individual pulses of the individual audio signal parts. I think so. No. So to hear this, you want to average these. This is what you're listening to. This average thing here. So I think we put on the scope, we would see this up here. If you come down here, there's a capacitor here. His job is to get rid of this stuff. So in this area, as opposed to up here, I think it would look differently because this coil is in the way. I think here you would see something more like this. Again, I don't know if this is really true. This is what I would say to be the case. And this is not necessarily zero here. Zero might be down here. That doesn't quite look right, but something like that. Again, I'm warning you, but don't listen to me. So the bulk of the current flow coming out of here is going to go straight down like that. Some small amount is going to be tapped off this way. Let's look at this branch for a minute. I mean, this is where the business is. The whole idea is to get this DC voltage from this rectifier out onto these grids. So these are the front end tubes that are controlled for the AVC circuit. So to get over to here, you got to get through a 1,000,000 ohm resistor. Now that's a really big resistor. It's just about any current flow in here would cause a voltage drop as big as the voltage that's pushing it. I mean, but the deal is there is no, or virtually no, current flow through here, because if you trace it all out, they all just go to these grids, which is basically going nowhere. So you don't expect any current flow through here. I mean, no voltage drop here or across these large ones, 100,000, 100,000, 100,000. Notice this, very important capacitor here. So the job of this capacitor is to make sure there's no AC signal in here left. So anything that's made it past this way, and anything that should work its way back on the grids. So for instance, each of these grids is being given a signal to work with. That signal can travel down here and end up on this line. But with this thing here, any little bit of signal that makes it through here is just going to be knocked away. This is a very big capacitor working a large, I shouldn't say big, relative to the little tiny guys that exist in this radio. This medium-sized capacitor is working with these very large resistors. So it doesn't take much capacitance to quiet this whole line right down. Almost certainly I've replaced this with a new capacitor, if it exists in the radio. Or is this missing too? Because it appears to me this is missing, and this is missing, and this is missing, and this is missing. No, these two exist. That's missing, that's missing, that's missing, that's missing. So with this one missing, I think there's a serious problem with the radio. You need this capacitor, even though it's not very big, to kill the RF part. You don't want the RF part continuing on. And really, you're just trying to get rid of it at this point. That's why it's just being directed right into the chassis. And this capacitor is working against these two resistors. These aren't the biggest resistors in the world. So as a signal comes along and has a choice, go here or go there, maybe some of it continues down in here. Some portion would, of course, but it could be so small as to be negligible. But maybe not. I don't know. The engineer sets the ratio of the capacitors, the resistors, all this stuff to create the situation that he wants. So current flows will tumble into the right places. The right current flows go to the right places. So this one is bypassed. This resistor is bypassed with this fairly large capacitor, 0.1. So that means AC wise, this ground point is actually sitting up here. The entire AC signal, which would be this part here, or maybe this part is what we're really talking about now. I think it's this part we're talking about. Is going to see this as a ground path. So it's all dropping across here. Now, how does it get out to the sound? How does it get onto the amplifier? So this is, I should draw another plate here. That's off to the rest of the amplifier that way. This grid is getting its audio signal through this capacitor from the volume control. The volume control is getting its signal from the other side of this resistor and this capacitor. Now look at how big this resistor is. That's pretty big. 500,000. Okay, I don't know what this is, but we could guess. Well, I could look. I won't worry about it just now. But it's probably 500,000 ohms here. I'm not sure though. So, and what exactly is this guy doing? I don't know. I don't understand what's going on here, unless this is just altering the audio response of the radio to bring it to normalize it so it sounds nice to our ears. Let me put it that way. So maybe that's what this is. I don't know. I don't know what's going on there. But this exists. So this is not my problem. My problem really starts over here. I really need to know what these guys are doing. I need to know what happened here. I need to know what happened between the connection from here to here. What happened? What happened here? I need to know if this capacitor is in place or not. So looking at it from the DC point of view now, the DC falls across here, all of it develops here, so it's all available here, even though there's no current. Whatever voltage shows up here is going to be showing up on all these. And the magic eye down here. The Vizio eye. So let's consider what he's got on here right now. So all this stuff disappears on the other side of everything west of the Mississippi River here doesn't exist. And this doesn't exist. So we're coming. See, I need to know what's going on at this point. I need to know what has happened. Perhaps this is still in place, because if this is just open circuited, I haven't got the vaguest idea how this radio would work. So there's something going on here I need to explore and find out how this has been treated. That's probably the very next thing to do, in fact. Because I don't know. Yeah, let's find this out right now. Let's find this out right now. Because the radio's right here. Just waiting for me. Okay. So what I want to find are these two wires here coming off the coil. Just a sec here. Things I do in the evening get in the way sometimes here. Okay, there we go. So this is the coil. It's got 4 wires coming out of it. We can quickly identify. No, I thought it was done already for a second there. No. We can identify. I think I identified these before, didn't I? On another diagram? Oh my gosh. Where's my other diagram? Did I don't think I did. No, you know, I did not draw any of this in. That's probably one of the reasons why I don't know where it goes yet. Okay, so one at a time. The primary wire. So we know this. This is the 6Q7. These are the diode connections. This goes to, this should go straight into this coil. And sure enough, here's the lead right here. Straight into the coil. So that's a secondary lead there. Now I want to find its brother. And here's the other lead. Coming to here, this capacitor resistor combination is this one right here. So what I'm seeing this wire right here going into the coil. So do I have this right or wrong? What have I got here? Yeah, then the other side of the coil. You know what? I had it right. I had it right when I had it wrong. So this is what he's done here. Okay, so I feel a little better. Why did I think for sure he had done the opposite? Because I traced this wire. I don't know, I guess maybe I got my eyes mixed up or something. Because clearly it comes from here into the coil, out of the coil, onto the diodes. From here into the coil, out of the coil, onto the diodes. Good. Okay, so I got this correct now. So where's this capacitor? Which should be on that piece there. So somewhere there should be a capacitor. See, I just don't see any, and that's it. It's got to be from here to there. Now there is a capacitor installed right here. Is that a mistake? I mean, I'm the one who installed it. Did I install this incorrectly, or did I match his error? Maybe I matched his error. So let's see. Oh, you know what? This isn't an active pin. So this is way too big a capacitor anyway. The capacitor is a 0.0001. It's a pretty small one. So I think that's the case. I think there's a capacitor missing here. You know, in approaching this in a stepwise manner, instead of all at once. You don't have to have a whole enchilada here necessarily. It could be that maybe making some small changes in here will correct things. So I found this. This does not appear to exist. I did not find this, and of course I did that test on the other video, kind of proving that there is no connection over this way. So if I wanted to make it, so basically, this point and this point are the same point. Potentially, it could be the same terminal even, and this is missing and this is missing. This is missing too. So with this missing, this is the main pipeline. If part of the main pipeline is missing, then the output of this, wow, some answers may come here. The output of this goes through the coil, of course. The coil has to be involved. And then bypasses 60,000 ohms and comes to 10,000 ohms. So that means the current flow in here would be potentially, I don't know, 5 times higher than expected. Didn't I give a long story about how to burn out this secondary coil? Okay, here's my new story. Guy makes changes to the radio. Gets rid of this resistor. Turns the radio on. Heavy current flow in the detector circuit burns out the secondary. He slumps down in his seat. Oh my God, what have I done now? He doesn't understand what's gone wrong because he's made some kind of mistake. Now he knows with this coil burned out, his only option is put a new coil in. He picks one from another radio, sticks it in there. Maybe that's okay. Maybe he really knew what he was doing and it's fine. Even though physically it looks smaller, maybe electrically it's just perfectly fine. Puts it in, doesn't install this resistor, continues to run it into this. Continues with the heavy current. This is a singing coil. This coil's singing. You can make me sing by making me hurt. Maybe that's what's going on in here. This coil is hurting. This coil is on its way to the same demise as the last one. But why not? Well, maybe it's a weaker circuit now. The new coil doesn't generate as much current in here. Or maybe the coil is stronger and it can take the current. And so the current is flowing, the same current that burned out the last coil is flowing in this one. Seems to me very risky thing to not have this resistor in place. Man, this one's not in place either. Wait a minute, my whole story just went down the drain. This doesn't exist either. Okay, that was a nice story, but it doesn't fit this radio. So this radio... So with this missing, then the output from this coil is hooked up just to a huge resistor, and in through here to ground. This is a big thing too. It's nothing like what it was. Nothing like what it was. Wow, this is hard to believe, isn't it? Because it's a huge difference between having a voltage divider to ground operating here, you're tapping off, versus pumping it down this wire straight through here. It's a completely different thing. It's kind of a shocker that the radio even works in well enough to be listened to. Now what? Now I should ask myself, did I really get this right? Are these parts are really truly missing, or have I just been fooled and they're at the end of a long wire? I've been looking for them up in this area for all that. Maybe they're way down here somewhere and I've just been fooled. There's lots of resistors in here. Maybe I've just been fooled. It's hard to believe this radio could work the way I think it's wired. Okay, so if it is the way I think it is, then I would want, now this is where the really becomes difficult. Why not reestablish this? Maybe the guy knew that with the coil he put in, the transformer he put in, he have to make the connections like this to make it work. So that's why he threw away all this, because it just doesn't matter. And he gave up on the AVC in the front end, because he knows the radio will still work. He did all this very rationally and made all these choices and knew exactly what was happening. And if that's the case, then I start trying to re-establish this, I run the risk of burning this coil out. Now if I burn this coil out, I don't have a pile of radios in the back to go yank another transformer from. If I burn this guy out, there'll be some splaining to do. So another approach to this kind of problem is there something I can do to improve the operation of the radio given the way it's wired up and all the question marks all over the place? Is there something I can do to improve this without wholesale re-establishing the original circuitry? Another question is, are there some experiments I could do where I could partially re-establish this, or I could have it running the way it is and then establish, let's say, this arrangement here, and then compare how the radio is operating. Is there something I can do to protect this coil so there's no way I can burn it out? So my earlier thinking was this coil got burned out because of a short on this capacitor. It's still possible, but there's many other ways now that something could have happened here. See, why, if he knew enough to hook the eye up here, the eye grid here, whoops, what am I talking about? Yes, he's hooked the eye. That's why I'm getting confused. I'm getting the eye grid connection confused with this wire. That's why I keep drawing it up here and down here. This grid connection, which is supposed to be over here with all the rest of the tubes, is actually up here with a resistor. So, knowing that there's no AVC out here anymore, the magic eye would not operate, just like these won't operate. But nobody's going to figure this out, but this will be obvious if it's not operating. So with this circuit abandoned, his only option, hook this where there is some varying AVC voltage. Hook it here. He has no options. Or he had it hooked here, the thing wouldn't work, he couldn't sort out what happened, so he started poking around and then hooked this up over here. The guy's smart enough to figure all that out. He's also smart enough to figure out why there's no AVC here and to reestablish it. But he didn't. So what would be the problem with that? So if he's got this arrangement and you can pick up AVC here because you can see it working on the eye, why not send it over? Why not? Why not? Because wow, okay, so this isn't here. So we just got this to here. So we basically have a voltage divider now, dividing the output of the detector. This guy are dividing it. So he's 500,000. This, I'm guessing this is 500,000 also. So the output is dropping in half. In fact, there's a bypass here. It's a large resistor. It's a kind of a bit of a smallish capacitor, but maybe much of the audio is actually going around this way, and all of it dropping across here, which would be a desirable thing, I guess. And if all of it is dropping across here, as opposed to here and here, voltage divider, a bit here, then the output of the radio would be elevated. and you wouldn't need to turn this control up very high to get a lot of volume. That's the way this radio works. So the resistance on this side very high, down here. And of course up this way is just an open wire essentially. So there's virtually no pull through here. No current. So moving the volume control up and down isn't going to unbalance these two large resistors that are making the voltage divider. So that's probably how it's working. Probably. And then what about the RF? So the RF is going to be blasting down through here. This would be the IF frequency. Give right through this guy, right through this. My God, if audio can sneak through here, then surely the RF would go right through it. So you'd have all the RF right across the volume control. It's another thing we could scope. Yeah, why don't we track this with this scope? Find out if I have anything I've been saying is in any way true. There we go. I got lots of hypotheses running now. Put this guy over here. Yeah, I'm going to stop for a minute, just get this set up and ready to go. It's going to take a few minutes to get everything happening. Okay, let's see if we're ready to start this guy up. And I think just behind here you can see, hey, what's that? That's a Geiger counter going back there. So if you hear a little tick, little ticks, that's the Geiger counter. Okay, more on that much later. There'll be a video on that Geiger counter later. Geiger counter and radioactive radios. Yeah, that's where I'm heading with that. So I think we're all set to go here. Pop on the power, got the signal generator going, got the scope ready as much as I can at this point. I think the radio is just the way I left it yesterday. So with any luck, it's actually going to, make sound. Headphones, Jim. Headphones. We're not too interested in the sound other than to verify the radio's operating normally before we get going. Okay, so put a little volume on here. Oh, you know what? The wires are not connected, Jim. Look where I'm at now. Where I'm at now. Okay, let me hook those up. Okay, turns out it is hooked up already. Why aren't we hearing anything? Maybe I don't have the volume turned up here. Okay, hang on. Tone. That's not volume here. Oh no, volume's up a bit. Oh, what's going on? What's happening here? There it is. I believe what we're suffering from is no antenna. No, we're not suffering from no antenna. So this is the signal generator connection to the antenna on the radio. So why we're not hearing the signal generator? Because something's tuned around here. Okay, so what I'm doing, I'm just tuning the despite the hum. Ignore the hum. Oh, now we're ready on the scope here. We don't really need to listen to that. So, scope connection. First thing we want to look at is right on the, I'd say, right on the output of the detector. Diode's the same place that the Magic Eye wire is connected. Magic Eye is closed right at the moment too, indicating a strong signal. So I think there's too much going to the Magic Eye. That's what I think out of this arrangement. So I'm just gonna, let's listen to this a little bit in case I kill it when I do this. So some interesting things there for a moment, but what's that all about? Why is it so shaky? So there's what we've got. Okay, it looks go a little bit smaller. Oh. Okay, so what's happening is my scope won't trigger very. It's not friendly on the trigger here. There. Must be triggering on that. That's really interesting. A lot of detail in there you can't quite see. Okay, but basically it is showing what I had envisioned here. Kind of, except I got this wrong. It doesn't show it cut off like this. That's right, I did get it wrong. I want to draw this right. This would be right. And it's going to look like this. And this is not a rectified thing. This is the actual audio we're listening to, kind of going like that. Okay, got my head clear on that. Yes. Thank you, scope. My imagination was a little off, but that's fine. That's exactly what we would expect there. Now, where we're looking here, we're looking right here, where we expect all the RF to still be. If we come down the other side of the coil here, certainly if this capacitor is in place, we shouldn't see all that RF. So I'm going to hook up here. This happens to be the place where the audio is taken off. So I can come down, I can find that on this side here, I think. This side of here. Let's go look at this side of here. So now that should be the audio signal. Ooh, what the heck have we got there? Let me see if I can just adjust the triggering here. It's just getting a little crowded in the shop here. You know what? It is triggering on that. I'm not sure what it's triggering on, but it's not really. It's not liking this very much. Scope's going to need some work soon. Yeah, okay. Can't get it to freeze. Good enough though. So I think if there were a capacitor on there, that wouldn't be filled like that. Wow, I'm really not sure what to make of that. To think about that signal for quite a while. Where's the zero? Where's the zero? Well, yeah, trigger won't show it. Yeah, bum. Well, let's flip it to DC and see what happens to it. Okay, so that gives us an idea of the DC voltage that's here. This is the 5 volt scale. 10, 15, about 15 or 20 DC volts there. 15 or 20 DC volts. I don't remember measuring that. Or 20. Same point, this meter. So I'm on the 50 volt scale, 15 volts, and I'm on the negative. So this is 15 negative volts at this point. Sounds like a nice ABC voltage. I'm gonna, just to verify that there is really a DC voltage sitting here, I'm gonna flip this back to DC. Okay. So you're looking at the AC and the DC signal at that point. I'm going to vary the signal strength coming to the radio, and we should see this move up and down. And it probably gets smaller too. Oh, wrong knob. Yeah, so you can see it moving down and getting smaller. So that's behaving just the way I would imagine it too. It's kind of interesting what happened there. I don't know. Yeah, what's interesting is sometimes there is some noise in here, and other times there isn't, and it seems to come and go with I don't know what. That's pretty interesting. It's gone. It's back. It's counterintuitive, eh? Wouldn't you say? Oh my gosh. So the chassis is grounded to the green wire third prong system in my house because I have the scope grounded here. This is just another one of those very same grounds. You can't really see it, but on the scope you can hear it. If you listen, there's no noise. Now there's noise. You can see it a little bit on the scope on the camera. Okay, just making lots of observations here in case one of them is important. So if I were to temporarily connect the capacitor here to ground, what would happen? On the schematic, it's a 0.0001. It's quite a small capacitor there. Okay, another place to look now would be on the volume control. What is reaching the volume control? So we would want to look at the output side of this. I'm on the input side of this. Let's go to the other side. This being capacitor resistor here. And this is what's heading for the volume control. It looks exactly the same. Lots of RF. So I mean, this is filled in with RF. Now, if I'm really hooked up to the volume control at this point, there's really just a shielded wire that runs from the point I'm connected to up to the volume control. Then what comes back? So this is what we're listening to at this point. I'm not listening to anything. This is what we're listening to coming back from the volume control. Okay, it's just a much lower signal. There it is. Okay, now it's really just loaded with RF problems here. So, you know, is that because that's what's on the circuit, or is that my scopy hookup here? Let's advance the volume control a little bit. Sure looks like RF there. What about, is there DC floating around there too? Okay, I'll vary the signal strength there. DC and the volume control. Now, the DC is blocked by this yellow capacitor right here. So what reaches the grid of the next tube, I will take a look at right now. So this is this is really what we're listening to. Listening to nothing again. Let me advance the signal strength a little bit. No show. Okay, that's just, I ain't got nothing left on my scope here. Let me force the scope to trigger. Come on, scope, you're being forced. that's too bad. That's too bad. How come I can't get at this? Are we really on something here? Let's just leave that off. So what's happening? There. What am I looking at? So now I'm looking at what is on the grid of the triode preamp. The preamp of the preamp in this radio. And it's just loaded with RF. It just doesn't look right at all. What I would expect to see there is a beautiful sine wave. Let me change the frequency of the signal here. Yeah, just making absolutely sure that's what we're seeing. So what to do at this point? Let me take a little capacitor. A little capacitor here. I'll actually install it briefly. I'll just try to finger it in there. 0.0001. That would be, what would that be? It'd be 1,000 picofarads, isn't that? 1,000 picofarads. Okay, I got 1,000 picofarads here. That's it. Grabbed it right out of the tray. So you want to ground almost anywhere, but the place they show it on the schematic, ground it right out of the coil, so it doesn't get anywhere in here. So same point where this wire connects. That's not really the way to the other end, which is why okay, I see where to do it. Okay, let's go back over here so we can watch the craziness happen. Now, the question is this going to knock out the doesn't that look great? Now, is that going to clean right up? That's the question. When I simply stick this in here, you know, I'm gonna clip lead the grounded end of this capacitor. Okay, this isn't really the best way to. We're dealing with RF here. You want short leads, but I'm gonna start this way because I think it's probably safer for me. Take my wet fingers. Yeah, that's good because I'm holding it like this now. Okay, so we make a momentary contact. Little guy right here. That didn't seem to help the case at all, did it? Knocked the audio out more than anything. What if I go on the other side? You see, I've hooked the scope up to a very high impedance circuit here. What if we go right on the grid here? This is the audio. This is the grid. So it doesn't matter at all there. And if we go on the other side of this, what if we just stick it everywhere? Just try everywhere, Jim. Everything, anything. Oh my gosh. So that didn't do anything I would have expected. So 0.01. Now it wouldn't. Why wouldn't it do anything? The output of the detector is facing a much higher resistance than it was originally intended. It's facing almost 1,000,000. So the detector is working into 1,000,000 ohms instead of working into 70,000. That's a whopper of a difference. So that would make a small capacitor even more effective at draining out the RF. Yeah, so there's something very defective with my thinking here. The scientific method is proving me wrong. That's why we do it this way. Right. Get a theory, see if it's true. Okay, so I'm stuck. My primary decision is, what should I do about this? We're listening to the radio. Sounds pretty good to me. I'm chasing down a theoretical problem while practically there's no problem. Is that the case? Well, the coil sings, which seems to me to be indicating a problem. Maybe what we should do is get the coil singing and try to see what that's all about. How would I ever do that? So let's just work on the scope signal just a little bit here. What I'm going to do is I'm going to speed up my scope trace way up. See if we can get a better look at the high frequency here. Yikes. So this is one ugly. Yeah, you're seeing it in the camera. You're seeing what I'm seeing. That is one ugly. Now I can just see if I can just bring that back here. Okay, so that's triggering effects you're seeing there. So again, we're looking at the grid of the first audio triode. Let me vary the frequency here. Oh, it's not even showing up. Well, what's with the pop? Oh, of course we can't see the audio signal. I'm up at this frequency. We can't see it. Right. So goodness knows what all this stuff is. Wow. So I would say the only reason we can't hear all the hash that's in there is you can't hear the hash. It's too high a frequency. It's certainly not going to be reproduced by the speaker. It's not going to get through some of these choke coils and other things that are in the audio circuits, but I think this is a mess, even though it sounds pretty good. Wow, okay, I gotta stop and think about things a little bit here. It's not clear to me at all what I should do next. So, and thanks a lot for watching. Unfortunately, it's just kind of a dead ender at the moment.